Everybody say hi, Kira.
Hi, Kira.
All right, there we go. We are still in section 4.1. We're going to hopefully finish the notes for 4.1 today. This is long and synthetic division. All right, here's what I want you to do on the notes. We went over some long division stuff on Thursday. We're going to start with example 3, and then we're going to go back and do some synthetic division, okay? So bumping down to example 3, we're going to do long division of this guy, and then we're going to move on, okay? So long division. All right, now, you want to put your box, and this stuff goes underneath of the box, okay? Do we need to add zeros to this guy?
No.
X to the third minus 4x squared.
No.
We have 3x and then minus 2. Nope, he's good to go. But, look at what we're dividing by. 2x squared plus 1.
Yes.
You do need to add a 0 in there. That's kind of weird. So I'm going to put plus 0x plus 1. Okay? So, just FYI, when you are dividing, the stuff inside of here, you need to put a 0 in if he needs a 0, but also the stuff that's out here needs a 0 as well if he needs a 0, right? You have to put them in on both sides. Otherwise, you're going to end up with stuff messed up. Okay? All right, are we good? We ready to divide? Okay, get him set up, ready to go. There he is. You need to put the 0 in there. You have to put the 0 in.
Why do we have to do that?
Otherwise, it's going to mess up your spacing. Your spacing will not be in the right spots.
Why? Oh,
Because when you end up multiplying through, like when you do, like, let's say you put a 3x here, right? If you did not put that 0 in, you would end up with 3x over here. And you want this to be lined up as the x squared stuff. Does that make sense? So you have to put a 0 in that spot. Otherwise, he's going to end up not being lined up correctly, okay? So you have to put your zeros in, all right? Are we ready to begin? Okay, here we go. All right, starting with 6x to the third. We're just looking at the leading parts. And 2x squared. He needs a 3x, Mallory just said, and I just put it up there as well. Then we multiply back through. So 3x times 2x squared is 6x to the third, okay? Then I keep multiplying. What is 3x times 0x?
plus 0x.
3 times 0 is 0, and x times x is x squared. So I have 0x squared. I'm going to make him positive, whatever, it doesn't matter, right? 0x squared is the same thing as negative 0x squared. And then 3 times x is plus 3x, okay? And we got to flip all the signs, right? Okay. Minus, this becomes minus, this becomes minus. So we're subtracting everything. That goes away, yeah? Okay, that cancels out. Then we drop down. How many x squareds do I have now? Hold on. How many x squareds?
1.
Make sure the negative goes with it. Negative 4x squared. Okay, the 3x's go away, so I'm going to put plus 0x, right? That canceled out. And I'm going to drop down the minus 2, okay? All right, so I'm still leaving that kind of placeholder in there of the zeros, okay? Now I begin again. Let me erase some stuff. Hold on. Let me erase some stuff. Okay, so I'm looking at negative 4x squared and 2x. Negative 2. So minus 2 he needs. All right, then we multiply back through. What's negative 2 times 2x squared? Negative 4x squared. Okay. Then negative 2 times 0x is minus 0x. And then 1 times negative 2 is negative 2. Okay. And then I flip the sign, so plus, plus, plus all the way through, whatever.
So that's it.
That cancels out, that cancels out, that cancels out. So what does that mean?
There's no remainder.
Nothing.
This guy has no remainder. All right, the question was asking, though, it said determine if, let me get rid of all this stuff.
Yes, it is.
Determine if this is a factor of that. Okay, how do you know if it's a factor?
There's no remainder.
Factor? Question mark? Yes. If no remainder. That's how you decide. If it has no remainder, it's a factor. So this one is a yes, because there is no remainder. Yes? Happy with that?
Yep.
That is long division, okay? Synthetic division is what we're doing next, okay? Now, you are going to like synthetic division better than long division, okay? I'm going to preface with that, but there is, you will not always on every problem be able to use synthetic division, and I'm going to explain to you like where you can't, okay? So going up here, this one, we are allowed to use synthetic division on. Here's how we're going to set it up. Ready? your box for synthetic division is going to go the opposite direction. So I go like this. This is what he looks like, and he's a big box.
Why not?
Okay, this is what your box for synthetic division looks like. Set him up. Go. Set him up. Go. Set him up.
I
Go.
might remember doing
Synthetic division. Your box goes the other way. Okay?
I've heard.
All right. This one's not bad. You like this. It's not bad. Okay? All right. Then you look at these numbers. This is what you're going to put in this spot right here. You got to watch and you got to listen, folks. Shush. You got to watch and you got to listen. Okay? The numbers that you get for coefficients here are going to go in these spots right here. Okay? All right. So the number that's in front of your x to the 5th power is a 1. You're going to put a 1 up here at the top. Then the next number is 5. Make it spaced apart evenly so these don't just look like numbers going straight across. Okay, what's the next number? 6. Then the next number is -1. Then the next number is 4. Then the next number is 29. Oh, shoot. Did we check to make sure we don't have any zeros that we need to add in there?
Nope, we didn't.
Nope, but we don't. We have an x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and nothing else, right? Okay, so we're good to go?
Not a question related to that at all, but
What?
when you factor the exclamation mark thing, can it only be whole numbers?
Yes. Yes. Okay. All right. Now, this is the tricky part, folks. We are dividing by x plus 3, right? Okay. Now, the number that goes on the outside here, this number is not 3.
4.
No.
Okay.
2.
The number that goes on the outside there is not 3. If I set x plus 3 equal to 0,
-3.
I subtract the 3 over. X equals -3. That is the tricky part there. You have to make sure you always remember that.
So,
The number that goes on the outside there will always be the opposite sign of what he is that you're dividing by. Does that make sense? Okay, now, the reason why you do that, check this. Listen to this very carefully. The reason why you do that, why you switch the sign of this guy. Remember when we were doing the long division and you would write everything and then you'd have to flip the sign of everything. Then you'd write everything and you'd have to flip the sign. And you'd write everything and you'd have to flip the sign. By flipping the sign once there, you don't have to do it again. Does that make sense? That's why we flip the sign to begin with, is so we don't have to keep flipping like you do in long division. Happy with that?
yeah.
Okay, here we go. In synthetic division, this is synthetic. You guys are going to like this. This goes fast. Are you ready? The very first step is you drop the 1 down. That's all you do.
All right.
You drop the 1 down. Pretty easy. Then you multiply. You multiply everything by this -3. What is 1 times -3? -3. You put it in that spot, right? Right underneath of the 5. That's where he goes.
Oh, 5.
Okay? All right, hold on. So the next one, you are adding those. 5 and -3 makes 2. And now what do you do with the 2?
Multiply by negative.
Multiply by the -3, right? And that becomes -6, right? Okay? And then we add those. 6 and -6 becomes
7,
0. Then I multiply again. -3 times 0.
8,
Okay? Is 0. -1 and 0 together make -1. Now I multiply again. What's -3 times -1?
3,
Is +3, right? 4 and 3 makes
7,
7, okay? And then I multiply again. -3 times 7 is -21. And then I add those, and that is 8. Okay, now, do me a favor really quick. And the very last number, put a box around it. That number is your remainder. Okay, so that number is your remainder. All right, now here's the deal. The number that we started with, okay, we still have to put this back together. We still have to create a polynomial out of this stuff, all right? Let's look at what we were dividing by, right? Okay, the first exponent here, take a look at this guy. This was an x to the 5th power, right? Subtract 1. Your first guy here is going to be x to the 4th power, right? This is going to start with x to the 4th power, and then you're going to work your way down, right? Okay? So I have 1x to the 4th power. You can just put x to the 4th. Then what? Plus 2x to the 3rd. You don't have to put this 0 in there, but that would be x squared, right? Okay? What comes next?
-1x.
Minus 1x, or just minus x. Then plus 7 plus
8 over x.
8 over x plus 3. Okay? So because that 0,
Wait, why did we
that
take-
0x squared was not in there, you don't have to put the 0x in there. Okay? Because we are dividing, we're taking x to the 5th and we're dividing by an x, right? We're dividing by an x. That's why he should start out with x to the 4th. Does that make sense? Right? X to the 5th divided by x to the 1st power is x to the 4th. That's why we start with x to the 4th going down. Does that make sense?
Yeah.
Yes? Yes? Okay. That's synthetic division. It's kind of a little nicer than long, right?
Yes.
It's kind of a little, but there is a lot of opportunity for incorrect things, especially if you mess up a plus minus, right? Okay, on synthetic division, same thing as long. If you screw up in the beginning, your whole rest of your pieces is going to be wrong, right? Good? Happy with that? Do you want to do another synthetic, or are we good to go?
No, I doubt it.
We're good to go. Okay, that one's easy. All right, moving on to the next page. Moving on to the next page. Okay, example 4. I'm just going to show you this next example, and this is x to the 79th power plus 3x to the 24th power plus 5, and we have to like do this thing here, okay? So there is a trick, and we're dividing by x minus 1. Circle that guy. Circle x minus 1. We're dividing by x minus 1. I do not want to have to write all of that stuff out there because all of the x's in between there, like x to the 78th power, I would have to put a 0 in front, and I would have to put 0x to the 77th power, etc. I don't want to write that out. That would fill my whole page, even if I went lengthwise. I would not be able to do that. But what we're trying to do is we're trying to locate what the remainder is. There is a way to cheat to figure out what the remainder is. Okay? There's a way to cheat to figure out what the remainder is, and it is this. Okay? This little box right here says, when you are dividing by something, like x minus 1 is what we're dividing by, what I can do is I can set this equal to 0 and solve for x. What would x be in that case? 1. I can take 1 and I can plug it in there, and that will tell me what the remainder would be.
So it's 3.
Okay? So, if I, what? What are you doing?
What are you saying?
No.
Plug it into the whole
You're
thing?
plugging positive 1 into here, right, for the x's, okay? So I'm going to plug in. Plug in. Okay? So 1 to the 79th power plus 3 times 1 to the 24th power plus 5. Yeah?
Yeah.
Okay? What's 1 to the 79th power?
1.
1. What's 1 to the 24th power?
1.
1 times 3 is
3.
3 plus 5. If I would divide this whole thing out, the remainder would be 9. That's what my remainder would be. Okay, now here's the next question that they're going to get to. You guys understand what we just did? When you are dividing, you can just take that number and plug it in, and that tells you your remainder. Okay, there's the next question. They are not asking it yet, but they will. Does this thing go into here evenly?
No.
Why?
Because there's a remainder.
Because there's a remainder, right? Okay? So, if this thing went in here evenly, what would this number be? 0, right? It would have 0 remainder, okay? That's the next question that they're going to be asking. Does that make sense? Do I need to say that again?
No.
Louder for the people in the back. Craig, did you get that?
I got it.
Okay. So, there is a remainder of 9, so this does not go in there perfectly. Let's look at this one, okay? Find the remainder when we're taking this guy and we're dividing by x plus 2. Okay, so x equals, that's the first thing Mallory's doing, x equals negative 2. We're going to take that negative 2 and we're going to plug it in here. Okay, negative 2 to the 4th power, what's that become? Positive 16. 16 times 3 is 48, I believe. Okay, negative 2 squared is 4. 4 times negative 8? Negative 32. Let's keep going. 11 times negative 2 is minus 22 plus 1. That's what we're adding together, right? Okay. All right. What's 48 minus 32? 16. Yes. 16 minus 22? Negative 6 plus 1? So what does that tell me?
There's a remainder.
If dividing. Whoop.
Is that 48?
If dividing. Your remainder is?
Negative?
Negative 5. If you're dividing, your remainder is negative 5. So,
You have a negative remainder.
you can have a negative remainder.
Because you can?
Like you're dividing by a negative. Right? You can have a negative remainder. It seems kind of weird that would be the thing. But if your dividing remainder is -5. So, does this thing go into here perfectly?
No.
No, because what would your remainder have to be?
0.
0. Yes? Okay, let's go on down here. Show that this thing is a factor of this guy.
Okay, so if it doesn't come out to 0.
Okay, so how do I show that this thing is a factor of this guy? I don't want to divide.
Plug in 3 and see if it's 0.
Plug in 3 and see if it's 0. If x minus 3 is what I'm dividing by, then that means x equals 3. I'm going to plug 3 into here. Okay, 3 to the third power minus 4 times 3 squared plus 2 times 3 plus 3. Okay, what's that have to come out to be? If that's a factor of it, that means my remainder is 0. Okay, let's check to see if it does. 3 to the third power is 27. 3 squared is 9 times 4 is minus 36 plus 6 plus 3. Okay, let's check it and see if it works. What's 27 minus 36?
Negative something.
-9 plus 6 is -3 plus 3 is 0. Okay? Good? Yes? Happy with that? Okay, now it wants me to actually find that value. It says find Q such that, look at this stuff. Find Q such that whatever I take times x minus 3 will give me this thing. So how do I find the Q? They want me to actually find the remainder, or actually find the thing after you divide it, okay? How would you like to divide this? Synthetic division, okay? That's your favorite. Great, okay? We're going to do some synthetic divide. All right. There's my box on the outside. What number goes on the outside here?
Where did you get 7?
What are you talking about? That's a 27. That's a 27. Okay. Now, Q of x is what we're getting after we divide. Okay. So what number goes on the outside again? 3, right? Because we're dividing by x minus 3, right? X minus 3, that number goes on the outside. Okay. So we're putting our coefficients here into this spot. Now, do we need to put zeros in anywhere? It goes x to the third, x to the second, x to the first, and then nothing. Okay. So my numbers are 1, -4, 2, and 3. Okay. Drop the 1.
3.
Multiplied together gives you 3. Okay. -1. If you add 3 times -1 is -3. -1. And I multiply that, that's -3, and this guy is 0, as he should be, right? This number should end up being the same as this number when I plug in, okay? Here you go, folks. When you are expected to do this on your homework or on a test or anything like that, if I ask you to do long or synthetic division, it would be a really, really good idea for you at the end to just plug that number in like we did over here and make sure that this number is the same as this number. That's a really good idea to check.
Yeah.
Yes, right? Especially if you get a number that's weird, like 103, right? Let's say you got 103 as that number and you're like, oh crap, is that number even right? Plug it in really quick. It's not hard to plug in to see if that's the correct remainder, right? Okay, now, what does this come out to be? Like, what is that written out? What x value do we start with?
Third.
Okay, we're dividing x to the third. So we should have x to the second. So this guy right here should be x to the second. This is an x, and that's just a number, right? Yes? Makes sense? So,
one number?
yes, because you're taking an x to the third and you're dividing an x off, right?
Wait, what?
We're starting with x to the second. Minus x minus 1. This is what I get when I divide. Okay, let me go through that again so you know. I'm taking an x to the third power. That's the highest power here. And I'm dividing by x minus 3. That means I'm dividing an x off, right? X to the third divided by x means we're starting with x squared. Okay? Happy with that? Makes sense? Good? Okay? Now, you guys like synthetic division better, correct?
Correct.
Okay? Now, here's the deal though, folks. Synthetic division does not always work. If you go back to example 3, just look at my example 3. This is the first example we did today. You cannot do synthetic division with something that looks like that because it's x squared. So in that case, you have to use long division. right? Otherwise, we might as well use synthetic division for everything, right? Because it's easier. But when it's not just an x plus something or x minus something, you have to use long division, correct? Okay? All right, so that's why we have to know the long division stuff too. Okay, here we go. The fundamental polynomial connections, whatever. Here we go. All right, they want us to look at this and they want us to find the x-intercepts of the graph of f. Let's graph this thing. Can we do that?
No.
Yeah, let's graph it. Let's graph it. 15x to the third minus x squared minus 11x plus 72. You people with your graphing calculators, everybody get them out and plug it in and see what we get. Okay? Plug your 15x to the third minus x squared minus 1114x.
It's dead.
You want me to cry?
Okay, then you need to go plug it in.
How is mine not dead? That's my question.
All right, where do you go to plug him in?
Y equals.
Y equals. Okay, clear everything else out.
Where's the charger?
Plug him in.
To the third.
15x to the third. Just wait and I'll help you here later.
Where?
15x to the third minus x squared minus 114x plus 72. I'm going to make sure Windows negative 10 to 10 and negative 10 to 10, and Rachel says it doesn't work. Does it work?
Yes, it does.
It does? Woo! What the heck is going on here?
Look at mine, it works.
The x-intercept
It's a, oh my
Okay.
God.
Okay, do you know what an x to the third power function looks like? X to the third power looks something like maybe like this, right?
Yeah.
Okay?
That is not
So that's kind of what mine looks like. It's off the screen though. Mine does this. It goes like all the way up, right? And then it comes back down here. And then it goes all the way back up again. Something like that, right? That's what he looks like. And my window's only showing like this chunk of it right here, right? Okay? But he is crossing at 3 places. They are this one, this one, this one. And they want us to find those places, okay?
Can't you do that?
I think I broke the calculator.
You can go second.
You know, I don't know.
How did we do that?
Oh, that looks about right.
No, when you do it,
Here's my
it'll give you the
computer.
numbers without.
If you go to the table,
There's a 1% chance.
you could go to the table.
My
Second graph.
calculator
Okay.
is
All right. This place I know really nicely where it crosses. Do you see him?
Whoops, that's not it. Help.
I can't.
He's at -3, right?
This thing's frozen.
Okay. It's frozen. Go to your window.
It's
Change of
taking
negative 10 to 10.
I can't.
Okay, then that's because he's still graphing. So you gotta wait. Okay? I see that really nicely at -3, yes? Do you guys see a -3 over there? And then the other ones are kind of like in between places. So here's what we're gonna do. I know that one of the x-intercepts is -3. And the other two are like places I don't really know. So here's what we're gonna do. We're going to divide off the -3. Yep. Let's divide off the -3 from this guy and see what we're left over with to find the other
Did
two
you just
exactly.
zoom in to find -3?
Kind of.
Find -3.
It's going through -3 exactly, is it not?
The other
I
one's
don't know.
3.
How'd you find it?
The other one is 3. No, it's not. It's not crossing 3 exactly.
Ow.
Nope. Look.
No, he's not crossing 3 exactly. It looks like he's crossing 2.5.
1.
Okay, so I see him crossing really nicely at -3. Let's divide the -3 off. Okay, so I'm going to put -3 over here, and I'm going to put all my other coefficients. So 15, -1, -114, and 72. Do you see what I just did?
15.
-3 is one of my answers. We're going to divide him off. Okay, all right, so first thing, we drop down the 15. Multiply gives me -45. Okay, then I add them, that's -46. And if I multiply, what's -3 times -46?
That would be it. -18. Negative.
Positive.
What?
It's
138. Perfect. Positive 138. Okay, next. If I add those together, -114 and positive 36 is 24. Okay, now -3 times 24 is -72, which means my remainder is 0. Okay, let's put him back together. I had an x to the third power to start with.
15x squared.
So this is 15x squared
minus 46x
minus 46x
plus 24.
plus 24. There is that. Okay. Now, what would you like to do from here to find the other two? We could do like a quadratic, right? We could do quadratic. We could try a complex trinomial. Let's do a quadratic.
I don't know.
Okay. Let's do the quadratic. So negative b will be 46 plus and minus the square root of, what's 46 squared?
Yes.
46 squared.
Is 2116.
2116 minus 4 times a times c all over 2 times a. We're going to figure out what these decimal places are exactly. Exactly.
Couldn't we just look at the graph? and-
Because it won't be, if we look at the graph, we will guesstimate where it's crossing. We're going to find the exact place.
What's wrong with guessing?
We don't want to guesstimate in this
I'm gonna
case.
take this thing to graph.
Yeah.
Okay. 46 plus and minus. Okay, 4 times 15 times 24. This is 60, I know for sure. 60 times 24? I don't know.
That'd probably be 12.
1440? Okay, so this is 2116 minus 1440.
140.
2116
It'd
minus
be
1440 is 676. That comes out nicely.
I want to feel that.
All over 30. Okay, the square root of 676 is 26. Beautiful.
It's moving.
So I have 46 plus 26 over 30, and I have 46 minus 26 over 30.
You can't see it.
Okay, 46 plus 26 divided, wow. And I get 12 fifths, so 2.4.
Oh, wait. How did you get that? Oh, I subtract.
Okay, and you did the subtraction. What did you get for subtraction?
I did it on
Minus, I got 2/3,
the
which is 0.6 repeating.
Where do? Oh.
Something like that. Actually, let's do 2/3. I'm not going to circle 0.6 repeating. Yes, you will have to put that top part in parentheses. Otherwise, it's only going to divide the 26 by the 30.
Okay, that's what it is.
That's what it is. Yep. So you need to so you can either put it in as alpha y equals enter and make it into a fraction, or if you're just going to do like the whole thing across, you're going to put the top in parentheses. Okay? So 2.4 and 2/3. Woo! Okay, 2.4 is the other one, and 2/3 is the other one. There he is. Okay?
Whoa, 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 whoa.
There he is. There he is. Those are my other guys. Okay? Those are the three exactly. Now, you could have found those on the calculator, but I'm guessing you would have rounded it off. Like 2/3 is 0.6 repeating. You probably would have rounded off as like 0.67 or something, which technically is not exactly 2/3 because it's rounded, right?
Can
Okay?
you go back to the,
So-
the graph?
Something like this right here. So this is my 2/3 spot. Whoop. This is my 2/3. And this is my 2.4. That's what he is. Okay?
Why is there a box?
Because I'm saying this is the only thing that my window showed. Right? It didn't show the up above, and that's from -10 to 10, negative 10
I
to 10.
was gonna
Yeah,
say, I
yeah.
was like, why
All right, now,
is there a box?
B, C, D. Here we go. B says, what are the zeros?
The roots.
Isn't that exactly the same thing as asking
Yes.
for the x-intercepts?
Yeah.
C says, what are the solutions?
We also found that.
Isn't that the exact same thing as that? Okay, now D is not saying the same thing. This is the last thing. They want to know what the linear factors are, okay? So basically, if I would factor this down, what would the bubbles be inside of the parentheses?
-3 something. Oh, 0.
So it would be x plus 3, x minus 2.4, and x minus 2/3. This is what part D is asking for. Does that make sense?
No.
Okay? They want the linear factors, so they want those guys in the bubbles, in the parentheses, yeah? There he is. So just A, B, and C were asking for the same thing. D is asking kind of the same thing, but just a little bit differently. Okay? All right, you guys. Oh, wait. We do have some more. We do have some more.
Just say no.
Say.
Just say no, please.
Tomorrow.
Example 9 is really easy, but example 8 is easy too, but it's just whatever. Okay, find 3 polynomials of a different. We're just going to do one polynomial. We're just going to do one polynomial. Here we go. Okay, these are my zeros. There he is. Okay, those are my answers. I have solutions that are 1, 2, 3, and negative 5. So I want to find one polynomial that has 1, 2, 3, and negative 5. Okay.
Plug 'em in.
Now what this means is, this means that x equals 1, x equals 2, x equals 3, x equals negative 5. Yeah?
Yeah.
Okay, that's what those guys are. Now,
What?
in the parentheses, what would they have looked like?
X minus 1.
You betcha. Keep going.
X minus 2.
X minus 2.
X minus 3.
You betcha.
X
X
plus
plus
5.
5.
X plus 5, yeah. Okay, we're going to create a polynomial from this. So now what are we going to do? Foil. Now, I would suggest,
Yeah.
this isn't going to be too bad. I would suggest foiling these two, getting an answer, foiling these two, and then getting one big answer, okay? It's not going to be bad.
I thought we had to do
Okay.
them all together.
No. So let's foil just these two right here. So this is x squared minus 2x minus 1x
Holy Spirit.
plus 2. Shh. There's that. Okay?
And the other one.
If we put the middle two pieces together, it's x squared minus 3x plus 2. Yeah?
Yep.
There's what he looks like. Okay? Then let's do this guy. X squared plus 5x
Yeah.
minus 3x minus 15. So that is x squared plus 2x minus 15. There he is. Okay, now we have to multiply that together, right? There are 3 pieces and 3 pieces. Together, all after we multiply, should be how many? 1, 2, 3, 4, 5, 6, 7, 8, 9 total. Before we combine like terms, right? Okay, x squared makes x to the 4th. X squared plus 2x, or times 2x, plus 2x cubed. And x squared times negative 15, minus 15x squared, yeah? Okay, the middle chunk, I'm going to switch colors. Negative 3x times x squared is minus 3x cubed. Negative 3x times 2x is minus 6x squared. Negative 3x times negative 15 is plus 45x. Yeah? Okay, last piece. Last number. Did I do all that multiplication right?
English grades at
Shush,
33
shush,
now, not a 28
shush.
anymore.
Emma Carr, come on.
58 now.
2 times x squared. Guys, come on. We're almost done. 2 times 2x. 4x and 2 times negative 15 is minus 30. There we go. Last thing, let's put stuff together. All right, starting with x to the 4th. He's done. X to the 3rds, we have some that we can put together. We have 2x to the 3rd minus 3x to the 3rd. Negative x to the 3rd. Okay, he's done. We have a bunch of x squared, so negative 15 minus 6 plus 2. Negative 19 x squared. Okay. And 45x and 4x. 49x. And then, last thing, minus 30. There's my polynomial that has all of those as zeros. Holy cow, that's a lot. Woo! Okay, last question. This is nice. I really like this one. Okay, number 9 says state. No, what?
Maybe we should skip it.
Nope. We like this one. Okay, number 9 says this is my polynomial. How many points can this place cross, or how many zeros maximum can this one have?
1,
3, 4, 5, 6,
2.
4.
1,
Plug
2,
it in.
3, 4. It's a W.
But we're not gonna plug it in.
So 1.
I think we should.
Maximum. How many places can this thing cross?
1.
Look at the highest power. What's the highest power? 4. That's the maximum number of times it can cross. If it's x to the 5th power, that's the highest number it can cross. X squared is a parabola. Can cross a maximum of 2 places, right? If it's a parabola, x to the 3rd power can cross a maximum of 3 places. Yeah, nice. Okay, the maximum number. Now, it won't always cross that many times, right? It could still be a W and not cross at all, right? If it's above. But the maximum number it could cross is 4, right? Okay? All right, you guys have a sheet. You got lots of work to do.
Yeah.
There's not a lot of problems, but it is some division. So get going. All right? You got some time. There you go. Everybody say bye, Kira.
Hey, can you